Hello students, in this video we will be discussing about relative velocity, and this video is divided into three sections, in which first section is of definition. After that, in second section we will move to its graphical explanation, and the third section is of determination. So these are the three sections on which we will talk about relative velocity. So first we are moving with definition of relative velocity. So how can we define relative velocity is the question. So the word relative means that we are talking with respect to some other thing. Okay, so relative velocity of some object with respect to the other object when both are in motion is the time rate of change of position of the object with respect to the other one. Suppose I have two objects, object 1 and object 2, and I want to find the relative velocity of object 2 with respect to object 1, then I write it as v21. v21 means velocity of object 2 with respect to 1. It means this is the relative velocity of object 2 with respect to the first object when these both objects are in motion, both have some velocities. So then this relative velocity v21 means relative velocity of object 2 with respect to object 1 is the time rate of change of position of 2 with respect to 1. That means the rate of change of 2 with respect to 1. When we define simply the velocity, then we say the rate of change of position. तब वहाँ पर we don't mention with respect to what, but here we are defining relative velocity, so we have to mention with respect to this moving object. So we can define relative velocity as the relative velocity of object 2 with respect to object 1 when both are moving, both are in motion, is the time rate of change of position of object 2 with respect to object 1. So this is how we can define relative velocity. Now if we talk about the expression of relative velocity, so how we can give that? Suppose this is the object 1 moving with velocity v1, this is object 2 moving with velocity v2, and we want to find the relative velocity of object 2 with respect to object 1. So we are assuming that the position coordinates of the two objects are at t is equal to 0. We are assuming that at t is equal to 0 the position coordinate. Now the position coordinate, we are talking about 1D motion or a straight line motion, so it will be a single coordinate x only. So the position coordinate of these two objects at time t is equal to 0 is x1 0 and x2 0. At time t means after time t or at the instant time t, their position coordinates will be x1 at t and x2 at t. So these position coordinates at time t can be given in terms of these coordinates or the initial coordinates as x1 t is equal to x1 0 means initial position plus जितना डिस्टेंस ऑब्जेक्ट ने कवर किया इन टाइम t, एंड दैट डिस्टेंस जो वो ऑब्जेक्ट कवर करेगा इट विल बी इट्स स्पीड इनटू टाइम और वेलोसिटी इनटू टाइम, दैट मीन्स v1 इनटू t. सो ये ऑब्जेक्ट का इनिशियल पोजीशन था सपोज x1, at 0, this is its initial position. It is traveling with a velocity of v1 and this is its final position after time t. Then the distance, ये जो यहाँ इसने ट्रैवल किया, that distance will be vt. So वही हमने किया है कि x1 0 में vt ऐड करके we can find x1 t. Similarly for the second object, x2 t is its initial position plus the distance traveled by it, which is v2 into t. So these are the two equations, 1 and 2. Now if we subtract 1 from 2, that means x2 at t minus x1 at t is equal to x2 at 0 minus x1 at 0 plus v2 minus v1 t. So we subtract equation 1 from 2 and rearranging this we get x2 at t minus x2 at 0 minus x1 at t minus x1 at 0. This will be equal to v2 minus v1 into t. That means x2 t minus x2 0 is actually the displacement of object 2 in time t. Similarly, this is the displacement of object 1 in time t. Means उन्होंने कितना distance travel किया और कितना displace हुए. Displacement of object 2 in time t, this is the first bracket, minus displacement of object 1 in time t, and it is equal to v2 minus v1 into t. So we can write it as the difference of these two displacement actually gives us the relative displacement of 2 with respect to object 1. This is the displacement of 2 minus displacement of 1 gives us the displacement of object 2 with respect to object 1. Since it is in respect of object 1, that's why we call it as relative displacement, not displacement. Relative displacement of object 2 with respect to object 1 in time t, and it is equal to v2 minus v1 into t. So v2 minus v1 को हम कैसे लिख सकते हैं? Relative displacement of object 2 with respect to object 1 in time t upon the time taken, that is t. So v2 minus v1 is the relative displacement of 2 with respect to 1 in time t upon t. So that's why we call it as relative velocity. Means it depends on the relative displacement of 2 with 1 in t. So it is the relative velocity of t 2 with respect to 1. So relative velocity of object 2 with respect to object 1 is equal to v2 minus v1, and we write it as v21. It implies v21 is equal to v2 minus v1. Similarly, इसका opposite अगर हम देखेंगे, means relative displacement of object 1 with respect to object 2 upon time अगर होगा, then it will be v1 minus v2. Then it gives relative velocity of object 1 with respect to object 2. In that case, it is represented as v12 and is given as v1 minus v2. So v12 means velocity of 1 with respect to object 2. That is the relative velocity v12 and is given as v1 minus v2. v21 is relative velocity of object 2 with respect to object 1 and is given as v21 is equal to v2 minus v1. This is how we can define relative velocity. Now we will move to the section of graphical explanation. So here in graphical explanation of relative velocity, we are going to use position time graphs for two objects moving along a straight line, and we'll discuss relative velocity in three cases, that is when relative velocity is 0, when it is positive, and when it is negative. These are the three cases that we are going to discuss now. So we have two objects 1 and 2, right? We have two objects with velocities v1 and v2 respectively, and relative velocity of object 2 with respect to 1, that means v21, relative velocity of object 2 with respect to 1, that is v21, is equal to v2 minus v1. And now we are discussing three cases for it, that this v21 is 0, is positive, and is negative. So case 1. Case 1, when the two objects move with same velocity in same direction, that means v1 is equal to v2. So in case 1, we are discussing that the relative velocity v21 of object 2 with respect to 1 is 0. That means both objects have same velocity in same direction. In that case, their relative velocity is 0. That is, case 1 is v1 is equal to v2, which implies v21 is equal to 0, and that means x1 x2t minus x1t is equal to x2 0 minus x1 0. This means that the two objects remains a constant distance apart throughout their motion. वो जिस velocity से चल रहे हैं same उसी velocity से चलते रहेंगे throughout the motion, and those velocities are same for object 1 as well as for object 2. So for that case, the two objects remains a constant distance apart throughout their motion, and then in such condition the position time graph will be two parallel straight lines throughout the graph. Okay, so from initial position to the final position throughout the graph has two straight lines parallel to each other. So here we can show the graph like this. So the graph will be like this. There will be two parallel lines, one for object 1 and other for object 2, and throughout the motion these lines are constant distance apart. Now this is the case when the relative velocity between the two is 0. That means with respect to each other they don't have any velocity. That means the difference between the velocities of the two is 0, or they have the same velocity. This is the case when relative velocity v21 is 0. Now we are moving to the second case where we are going to take v21 as positive. Now v21 as positive means v2 minus v1 is positive. That means v2 is greater than v1. So we are assuming that the object 2 is moving faster in comparison to object 1. So in that case the position time graph gradually moves apart, means the separation between the two lines will increase as the velocity of an object is more than that of the other. So they are separated from each other now. So the relative separation, if we talk about the relative separation, that is x2t minus x1t, this relative separation increases. It will increase, and the amount of increase is v2 minus v1 after every second. If we put t is equal to 1, then this relative displacement or the separation between the two increases by the amount v2 minus v1 after every second. So in this case, the position time graph we get will have two lines. One is for object 1, other is for object 2, but these lines are such that they are gradually moving apart from each other. Let's see how we can make this. So on x-axis we have time, on y-axis we have position, and if this is the line for object 1, then object 2 will not be a straight line parallel to it, but it will move apart, because velocity of object 2 is more than that of object 1. v2 is more than v1, so it will move gradually apart from 1. So this is for object 1, this is for object 2, and the relative separation between the two lines will increase with time. This is their initial position, that means x1 at 0 and x2 at 0. Okay, so this is how the relative velocity works in case of v2 greater than v1. It is positive and the relative separation increases gradually with time. Now moving to case 3. Case 3 is when v21 is negative, or we can say that v2 is less than v1. Now initially object 2 is ahead of object 1, and because of that the separation, relative separation x2t minus x1t is positive. Now the relative separation between the two objects decreases. Now this decreases because the velocity of 2 is less than 1, so 1 will approach 2, or we can say the second object will slow down. Because of that the relative separation between the two first decreases till the two objects meet at some point, and that point will give us the value x1t equals x2t. And after this meeting point the separation becomes negative. That means x1 starts increasing than x2, means x1 is more than x2 की situation होगी. So the separation x2t minus x1t is negative. So what we have is, in this case relative separation x2t minus x1t is positive initially, means objects are moving with their velocities, but second object is slower in comparison to the first one. So after a certain time they will meet at some point, and जब उन दोनों का meeting point होगा, then in that case this relative separation becomes 0 and x2t equals हो जाएगा x1t के. After that meeting point first will continue to move in its pace, and second one from its pace, which is a bit slower than that of the first one. So their separation starts becoming negative. Then the relative separation between them, means x2t minus x1t, after meeting point becomes negative. So initially it is positive. At meeting point this separation is x2t minus x1t is 0, और we mean that x2 at t is equal to हो जाएगा x1 at t, and we call it as meeting point. After meeting point, x2t minus x1t is negative. So this is how the graph works. So let's see how we can make the graph. Again we are going to make position time graph. So on x-axis we will take time, and on y-axis we will take position. This is for time and this is for position. Now the graph for the first object is like this. This is the line for first object, and the second object will move a bit slower in comparison to the first object. So this is how the graphs look like. This is the line for object 1 and this one is for object 2. Initial position of 1, initial position of 2, and this is the position. This is the time t, which is the meeting point. So we call it as time of meeting. And at this point, this position is called position of meeting. So before meeting point, at this position, at these positions, the separation between x1 and x2, the relative separation is positive. At this particular point, this relative separation is 0, and after this point, the relative separation means, in this case, x2t minus x1t, this relative separation is negative. Here it is 0 and yahan par it is positive. So this is how we can explain relative velocity graphically. So after this, let's move to the third section of our video, that is the determination of relative velocity. So for that, we know if we have two objects, object A with some velocity VA, object B with some velocity VB, and we want to find the relative velocity of A with respect to B, that means VAB, then it is equal to VA minus VB, or we can write it as VA plus minus VB. This is how it works till now. But what if the two bodies are inclined to each other? Means the situation is something like that the velocity VA is along the vector OQ, that is VA vector, and OP as VB vector, and these two are inclined at an angle theta. And now we want to find VAB, that means velocity, relative velocity of A with respect to B. Then in this particular case, we can also apply this same law to find the relative velocity. Means this diagram, in this diagram we are going to modify it, as to apply this law we need minus VB. So we talk about minus VB, then it will be in a direction opposite to OP. Means OQ is same, this is VA vector, and this is angle theta, this is VB vector. We want minus VB. So minus VB is along a direction that is opposite to OP, means here. So this is the direction of minus VB, and it has magnitude same as OP. So we are representing it by P dash. So OP dash represent minus VB vector. Now if we add these two vectors, VA plus minus VB vector, we can find the value of relative velocity. So for this we are going to use the law of vector addition, that is called the parallelogram law of vector addition, and it can be done as, so we can take the resultant of this vector by forming a parallelogram with sides. Okay, so this is how it works. The resultant of these two vectors is along OR vector. The diagonal of this parallelogram formed by the adjacent vectors OQ and OP dash is the resultant of these two vectors, that is OR vector, and it is given as VAB vector. Now by using the laws of vector addition, we can find the magnitude of VAB. So the magnitude of VAB is under root VA square plus VB square plus 2VA VB cos. Now cos and angle between these two vectors, cos of angle between these two vectors. So POQ is theta, then the remaining angle is 180 minus theta. So magnitude of VAB is equal to under root VA square plus VB square plus 2VA VB cos 180 minus theta is minus cos theta, so it will be VA square, VAB is equal to under root VA square plus VB square minus 2 VA VB cos theta. So this is the magnitude of relative velocity VAB. But relative velocity is a vector quantity and it can't explained by magnitude only. We have to explain its direction also. So for the direction of this relative velocity VAB, we are assuming that this angle is beta and we will calculate this. So after finding beta, we can say that the relative velocity is at angle beta from this VA vector, right? So we are going to find beta. For that we will calculate tan beta. Now tan beta is, now tangent of beta can be find the vertical component change upon horizontal component change. So it will be VB sine 180 minus theta upon VA plus VB cos 180 minus theta. On solving this, we get tan beta is equal to VB sine theta upon VA minus VB cos theta. Now sin 180 minus theta is plus sin theta, cos 180 minus theta is minus cos theta. So we can say that beta is equal to tan inverse of this value, means VB sin theta upon VA minus VB cos theta. So this is the required value of beta which is used to explain the direction of relative velocity. Okay, so this is how it works, means the relative velocity VAB has magnitude under root VA square plus VB square minus 2 VA VB cos theta, and its direction is defined by an angle beta from VA vector, and that has value tan inverse VB sin theta upon VA minus VB cos theta. This gives the direction of relative velocity VAB. This is how it works. Okay, now there are two special cases also. When this theta is equal to 0 degree, in that case VAB, and theta is equal to 0 degree, in that case cos 0 is equal to 1, and the magnitude of VAB will be VA square plus VA square minus 2 VA VB ka under root. That means VA minus VB ka whole square and whole root, so it will be VA minus VB. So the case, special case 1 is when theta is equal to 0 degree. In that case the magnitude VAB is equal to under root VA square plus VB square minus 2 VA VB. It is under root VA minus VB ka square is equal to VA minus VB. And case 2 is when theta is equal to 180 degree. So theta 0 means they are parallel or along the same direction. Theta 180 means they are anti-parallel or moving in opposite direction. So in this case the magnitude VAB is equal to under root VA square plus VB square minus 2 VA VB, and cos 180 is again minus 1. So it is under root VA square plus VB square plus 2 VA VB. That means under root VA plus VB ka whole square, and it is equal to the sum of two velocities, that is VA plus VB. These are the two special cases for the magnitude of relative velocity AV, right? So this is all about the relative velocity, its definition, its graphical explanation and determination. That's all for the video. For further videos, stay tuned, be safe and keep studying. Thank you.